Okay, so let's take a look at the second question of the extensive challenges. It says that the 9 positive integer n with the digital pattern ABC, ABC, BBB is divisible by every integer from 1 to 17 inclusively. Okay, so it's divisible by 1, 2, 3, 4, 5, 6, 7, 8, all the way to 17. All the way to 17. So probably what we can do is write down all the numbers. 11, 12, 13, 14, 15, 16, 17. All right. So if this number is divisible by all these numbers, actually I can simplify this question a little bit. For example, I can cancel out the 1, because as long as it is divisible by any other numbers, it would be divisible by 1, right? So for the same reason, I can start to cancel out some numbers. So for example, 2, because other even numbers are also going to include it. Which means that in the end, I just need to have the highest power of 2 remaining, which is 16. And all the other powers of 2 can be cancelled, right? The same goes for 3. So only 9 needs to be there, where the others can be cancelled. For the 5, well, 5 is already the highest power, so it can stay there. And then for the 6, it is just a multiple of 2 and 3, so it's going to be eliminated. For the 7, it can stay there because it's a prime. For the 10, it's a multiple of 2 and 5. So if it is divisible by 5 and by 16, I don't need to write down the 10. For 11, a prime number, so we keep it. For 12, if it is divisible by 16 and by 9, it is definitely divisible by 12. Because 12 is just 3 times 4, right? So if it has factors of 3 and 4, it's divisible by 12. So 13, we can circle it. 14 is just 2 times 7, so we don't need it to be there. 15 is 3 times 5, don't need it to be there. And 17. So these are what we have remaining, okay? And if you look at the pattern ABC, ABC, BBB, you can see that ABC is repeating 2 times, and then we have 3 identical digits at the end of it. What do you think is going to be the identical digit? Well, we know that this number is divisible by 5, and it is divisible by 2, which means that it's going to end with a 0, because ending like divisible by 5, the number can only end with 0 or 5. But at the same time, it's divisible by 2. So it has to end with an even digit, right? So it means that B is equal to 0. Okay? So now I have already cleared the path for 5. And then we have repeating ABCs happening, which if you do a prime factorization to that pattern, you can see that ABC, ABC, BBB is equal to ABC times 1001 times 1000. Well, we know that 1001 is 3 times, it's 13 times 11 times 7, right? So it immediately crosses out these 3. And we already know that B is 0, so it's A0C times 13 times 11 times 7. And then 1000 is 8 times 125, which means that for the remaining A0C, it has to be divisible by 2, because it's only a factor of 8 there, so we need another 2 to make 16, right? So A0C, not AOC, that's a 0, A0C or ABC is divisible by 2, 9, and 17. So the smallest such number will be 2 times 9 times 17. Which is equal to 18 times 17. And the answer is going to be 18 times 17. That's 306. So it fits the requirement that B is 0, right? So A, B, C will be 3, 0, and 6. If I am doubling it, it becomes 612, which B is no longer 0, so we can't. That's the reason why 306 is the only solution for A, B, and C. So A is 3, B is 0, C is 6. That's the answer to this question. All right?